In this video, I am going to talk about the improper integrals. We have integral a to b f of x dx. If I say this integral value is improper, then we have three cases. Either the lower limit of the integral is infinity, or the upper limit of the integral is infinity, or both upper and lower limit of the integrals are infinity. So there will be three cases. Say for example, I have something like this, integral 1 to infinity 1 over x to the power 4 dx. So here my upper value of the integral is infinity. In the second example, we have minus infinity to 0 x over 1 plus x power 2 into dx. So here I have the lower integral value is infinity. Or if you see the third case, here both lower and upper limits are infinity. So these are the models we are going to discuss in this PowerPoint. If the limit is a finite value, then I say the improper integral is converges. It doesn't, then I say the integral value will be diverges. Remember these important notes. The value of log 1 is equal to 0. The value of log infinity equal to infinity. The value of log 0 equal to minus infinity. E to the power 0 is equal to 1. E power infinity is equal to infinity. And e power minus infinity is equal to 0. Let us move on to the problems. Question number 1. Evaluate the improper integral, integral 1 to infinity 1 over x to the power 4 into dx. So here, this is my a value, lower value, which is 1. This is my upper value b, which is infinity. So I have to rewrite the given problem as limit b approaches infinity, integral 1 to b x to the power minus 4 into dx. So this function x power 4, if I take up, it will become x power minus 4. Then by doing the integration, we will get x power minus 3 over minus 3. This I can write minus 1 over 3x power 3. Now substitute the upper value and lower value. In place of upper value, we have b. So this will be minus 1 over 3 into b power 3. Minus 1 over 3b to the power 3. And we have to substitute lower limit. Before lower limit, let me write a minus sign. There is a minus in the problem. So it will be plus 1 over, in place of x, if I substitute 1, I will get 1 over 3. So in this, I have to substitute limit b approaches infinity. So when you apply infinity, this term will become 0. So I have left with only 1 by 3. So final answer is 1 over 3. Question number 2, integral 1 to infinity 1 over x to the power 3 by 2. So again, here also, in place of the upper value, I have infinity. So let me rewrite this problem as limit b approaches infinity, integral 1 to b x to the power minus 3 by 2. If I integrate x power minus 3 by 2, that will give you x power minus 3 by 2 plus 1 divided by minus 3 by 2 plus 1. If I simplify, I will get x to the power minus half divided by minus half. Then this will become minus 2 over x to the power plus half. That is, I will bring this x power minus 1 by 2 to the down. Then further simplification, I can say this as minus 2 square root of x between the limits 1 and b. If I apply upper limit, I will get minus 2 by square root of b. Lower limit, this will give you plus 2. Then last step, let me replace b by infinity. So if I apply infinity, as I told you before, the first term will become 0. So I have left with 2. So answer for this integral is 2. Then I can say the given improper integral is converges because I am getting a finite value. Question number 3. Integral minus 1 to infinity e to the power minus 5x into dx. So step number 1. Let me rewrite the problem as limit b approaches infinity, integral minus 1 to b e to the power minus 5x into dx. then we know that integration of e power minus 5x will be e power minus 5x by minus 5 between minus 1 and b. If I apply upper limit, this will be e to the power minus b divided by 5. Then this minus will become plus, because before substitute lower limit we need to apply a minus. Then e to the power, I have to substitute x equal to minus 1, so this minus and this minus will become 1. So we have e to the power 5 divided by 5. Next step, this b I have to substitute infinity. So the first term will become e power minus 5 e power minus infinity plus e to the power 5 over 5. We know that e power minus infinity equal to 0. So my final answer is e to the power 5 divided by 5. Question number 4. Evaluate the improper integral minus infinity to infinity dx over 1 plus x squared. So what I do, we have minus infinity and we have infinity. We know that the middle value is 0. To evaluate this integral, I am going to do two subintervals. That is, first you have to take minus infinity to 0. Then we have to integrate 0 to infinity. So I will get minus infinity to 0 dx over 1 plus x power 2 plus 0 to infinity dx over 1 plus x power 2. So this is my integral I1 and this is my integral I2. So for if you see the first integration, we have lower limit as minus infinity. So what I do, I have to write limit a approaches minus infinity. Then we know that dx over 1 plus x power 2 is nothing but tan inverse of x. If I apply 0, I will get tan inverse of 0. If I apply a, I will get tan inverse of a. Tan inverse of 0, this value will be 0. And then this a, I have to apply minus infinity. So tan inverse of infinity value pi by 2. So tan inverse of minus infinity value is minus pi by 2. We have already a minus here. So minus times minus will give you plus pi by 2. Same way, if I do integration for the second one, if you see the second integral, there will be a infinity in the upper value. So I have to write limit b tends to infinity 0 to b dx over 1 plus x power 2. Then integration of 1 over x plus 2 will be tan inverse of x. Substitute upper limit b will give you tan inverse of b. Substitute lower limit 0 will give you tan inverse of 0. Now we change b equal to infinity. So this will become tan inverse of infinity. Tan inverse of infinity value pi by 2. Tan inverse of 0 value will be 0. So infinity minus 0 will give you pi by 2. Final answer, we have to add I1 and I2 result. I1 equal to pi by 2, I2 equal to pi by 2. So pi by 2 plus pi by 2 will give you 2 times pi by 2. By cancelling 2 and 2, we have left with pi as the answer. Next one. Sometimes you have integral 1 to infinity 1 over x to the power some value times dx. These problems we can easily identify the p-value and we have come to a conclusion whether the problem is converges or diverges. If I have p-value is more than 1, that is greater than 1, I can say the given integral is converges. If I have p-value equal to 1 or less than 1, then I can say this is a divergent value. For example, in this problem, I have x to the power 2. So here p-value is 2, which is greater than 1. So before proceeding the problem, I can simply say the problem is a convergent one. If I want to find the convergent value, then we have to do the previous method. So step number 1, I have to rewrite the problem as limit b approaches infinity 1 to b x to the power minus 2 into dx. Then integration of this will give you x to the power minus 1 by minus 1. So this x power minus 1 by minus 1 is nothing but minus 1 over x power plus 1. This minus exponent, if I come down, it will become 1 by x power 1. This is nothing but minus 1 by x. Then this x, I substitute the upper value b, the lower value 1. So that will give you minus 1 over b plus 1. Now last step, I apply b value as infinity. I will get the first term as 0. Then I can say the final answer is 1. Same way, evaluate the improper integral, integral 1 over x into dx. If I compare the p value with this condition, I come to know here p value is exactly equal to 1. So what I say, I can say the problem is going to be a diverges, or we will get a divergent value. Okay, let us calculate what is the value. So first step, we will write limit b approaches infinity, integral 1 to b 1 over x into dx. Integration of 1 over x will give you ln x between 1 to b. If I substitute upper limit, I will get ln b. If I substitute lower limit, I will get ln 1. Then if I replace b by infinity, I will get ln infinity ln 1. Ln infinity value infinity, ln 1 value 0. Infinity minus 0 will give you infinity. So I say the problem is diverges. Same way, integral 0 to infinity e to the power minus x by 2. So integration of e power minus x by 2 will give you e power minus x by 2 divided by minus 1 by 2. This I can write minus 2 times e power minus x by 2. If I apply upper limit, I will get minus 2 e power minus b by 2 minus of lower limit 0. So this will be e to the power 0. Then finally this b, I will substitute infinity. So I'm getting minus